So, welcome back. As you know, I am Eli, the computer guy, and I am here to try to provide you with authorityless, gatekeeperless, free to the end user technology education that hopefully empowers you to do whatever the hell it is that you want to do. Please do remember that free to the end user isn't actually free. All of this crap costs a surprising amount of money, so if you want to throw a couple of dollars into the crowdfunding campaign, that would be ever so lovely. Allow me to keep providing you folks education by providing me a couple of dollars. The capitalistic way. Anyways, it's kind of funny. I'm like looking at the camera right now, and somebody made a joke that I'm always wearing the exact same shirt whenever I do these videos. I'm not meaning to do this. To be honest with you, I'm truly not meaning to do this. Every time I come and I walk to the office, I just really like this shirt as a walking shirt. And so I picked this particular shirt and I walk to the office in it. I swear I have a lot more shirts. It's true! It's true! But anywho, that's not what y'all are here for. Y'all are here for layered security introduction. So this is, what is this, part 4, theoretically, of the cyber security program. And today we're gonna start getting into the things that you probably actually think about when you think about cyber security. Come on, Eli, let's get to the cool stuff. Again, I will keep reminding folks that the important stuff and the cool stuff aren't necessarily the same things. Again, this is actually important and cool. But employee policies, I swear to you, part 2, employee security policies, that is probably the most important video that it will do in this entire curriculum. And I can almost guarantee you it'll be the one that is least viewed. So anyways, make of that as you will. So what we're going to be talking about today is basically the overall concept of layering your security within your environment. It is important to understand that no one product provides you security, right? There is this idea that if you have antivirus, your environment is secure. If you have a firewall, your environment is secure. Or if you have this thing called Dojo, which was an absolute piece of crap, apparently people thought their environment was secure. All I need to do is plug in this one device, and I have been promised that my environment will be secure. And that is just stupid on the face of it. That's not how security works. Again, when we get into the computer world, a lot of times it's difficult to visualize some of the concepts that we're talking about when we're talking about viruses, when we're talking or antivirus software, when we're talking about firewalls, when we're talking about security policies and sharing policies and privileges and a lot of these things. You know, it can be a little bit difficult to just get that through your head, especially when you're new. But the way that I would think about security, and again, when we talk about layered security, think about this in the physical world, right? Simply having a lock doesn't provide overall security for a building, right? It's a component of the security for your building, but it's one thing, right? You have locks on your door. You have a security system, so if somebody breaks in, basically kicks in the door, that you will be notified. You may have a security guards on the premises. You may have a lot of other things, basically creating an overall security environment for your facility. And that's the same type of thing that you need to be thinking about when you're thinking about your infrastructure. Again, if you put a lock on a door, well, what happens if somebody kicks in the door? Again, I think about this from the Baltimore area. Again, penetration testing in the physical world. One of my neighbors in the Baltimore area, they screwed in bars. They screwed in bars on their window into the frame of their window. I'm going to tell you why that shouldn't happen. Because somebody in the neighborhood decided they really wanted in their house, and they kicked in the entire frame of the window. So basically, they had the bars. So the bars kept you from getting through the clear clad, the glass part of the window. And so just when the neighborhood people just kicked into the entire window frame. Thunk, right? And so one of the questions you have to ask yourself is, well, what happens if somebody kicks in the entire window frame? Do you have any kind of a security past that? And that's where you need this overall, you need an overall security architecture. When we start talking about layering security, one of the big things in the cybersecurity world is the idea is you put up a diagram of a castle, and with that diagram of a castle, you explain the concept of layering the security, right? So you will have a moat around the castle. You will have big walls around the castle. You'll have watchtowers with archers in the castle. You will have armed soldiers or armed knights or whatever in the castle. So if anybody comes in, they'll get chopped into pieces, right? There are a whole bunch of different security measures that have been created in order to make the castle secure. The castle is not secure because of the moat. A moat does not make a castle secure. The walls do not make a castle secure. The archery towers do not make a castle secure. All of those things together, you know, work until somebody brings out the cannon. As with all this stuff, it works right up until the day it doesn't. But anyways, we're not gonna go into hacking with quantum computers quite yet. But basically that's the idea when we're talking about layering security, is that we're going to be layering all of this different type of security within your infrastructure, so that if any one thing is penetrated, the next thing in line should basically be able to cover and keep your premises secure, your infrastructure secure. Basically my idea when I think about layered security is the concept that if somebody has a root credential for your main servers, basically it should be worthless to them. Now, to be clear, I'm not telling you to do this. I'm not telling you to do this. But from an intellectual standpoint, right, an intellectual problem, right? Basically, what I would say is you should create your infrastructure to such a degree that you could literally print the root username or the root user and the password on a billboard on the local interstate, and that your infrastructure should still be secure, because even if somebody had the root credentials, they won't be able to actually use them. If SSH is not available from the outside world, then even if somebody's on the outside world, and then they try to get in with SSH or something, they won't be able to do it because it's not accessible. If somebody is in the building itself, they've snuck into the building, or you have an employee that's deciding to do something stupid, if you've architected the network in such a way, again, they can't access those root servers using SSH. Again, even if they have that root or those root credentials, you should be relatively secure. And so this is one of the big things to be thinking about whenever you're going to be building out your infrastructure. Again, I talked a lot about the idea of a zero trust infrastructure in the modern world, and to be clear, I'm not doom and gloom. I'm not doom and gloom. I'm not talking about how the world is gonna end and how much worse everything is now than when I was a little boy. But the reality is in most modern infrastructure, you should be thinking about it as a zero trust environment. In the old days, 20 years ago, when I got my MCSD, we had a relatively high trust environments. Again, we had the computers that the company purchased. They connected to the domain controllers that the company purchased. The internet connection for an entire office was 1.544 megabits per second. Have fun hacking the crap out of that, right? Anyways, in that particular environment, it was a relatively high trust environment. You know, we had control over all of our devices. We issued all of the devices, so on and so forth. One of the things you need to be thinking about, though, in the modern world, again, in this BYOD world, in this world where most business networks are going to be gigabit per second connections, the whole 9 yards. Basically, the big question is what happens if somebody brings in a completely compromised laptop and dumps it into your network? What happens if somebody takes a completely compromised laptop, plugs it in to the local area network, and whatever is on that laptop can just run free? Right? What if there's remote access tools installed on the laptop? What if there's all kinds of nasty viruses and everything else installed on that laptop? Somebody just came in, plugged that same thing into your internal network. Go! What happens now? If you're like, oh, well, I guess it'll be like, an hour or two of figuring out what's going on, and then, terminating the account or whatever, finding the computer and locking it down. Yeah, it'll be a little bit of work to do after lunch, right? If you listen to that scenario and you think, okay, realistically, okay, that's an hour, that's 2 hours worth of work. We're probably going to see blips on the network, we're going to have to track the computer down, and then we're going to have to smack somebody in the wrist, right? If you're like, meh, right? If the idea of a completely compromised system coming into your internal network and you kind of yawn about it, hopefully that should be the right response because you've built your security infrastructure properly. Most of the time, though, if that actually happens in the real world, yeah. Everything is going to go to hell. Everything's going to get really, really, really bad really, really quickly. And so that's one of the things that I would be arguing with you folks, is thinking about this as zero trust environment. Do not think about how you protect your infrastructure from the outside world. Think about how you protect your infrastructure from everybody. the first thing you need to be thinking about when you start talking about layered security is you need to know what the hell you're dealing with. Again, especially with a lot of new tech professionals out there, a lot of new security professionals, they run out there and they want to work, right? Again, one of the weird things in the modern world is there's this idea of real work and this idea of fake work. The work that is worth my time and the work that's not worth my time. Again, documentation. Don't ask me why. Trying to get a technology professional to document anything is absolutely horrible. True story. I was talking to Louis Rossman. So Louis Rossman, the guy up in New York City who repairs Apple computers. Anyways, he got some money for a 501c3, basically created a nonprofit organization. He was trying to do this whole educational thing on how to repair Mac computers and electronic computers and all that kind of stuff. And basically, he has money. He's funded with this, well funded for this 501c3. And he actually went to professionals that repair electronic devices and said, I will pay you, thunk, this amount of money to simply write documentation. Nobody took him up on the offer. True story. I don't know what it is. Technology professionals hate documenting stuff. But anyways, that's one of the big problems we run into in the real world of being a professional. Something that you need to be thinking about as you try to move your career forward is when nobody on the team wants to do something, the one person on the team that's willing to do the work that actually needs to be done is most likely going to get promoted. Why did they get promoted? Well, because they documented everything, they communicated with all of the end users and all of the stakeholders, they started developing plans for things that we could do in the future, and you all have been bitching for the past 6 months. Who do you think we were going to promote? Right? Anyways, real world. One of the big problems that you run into in the real technology world is, do you know what the hell your infrastructure looks like? And again, that sounds really snarky. Okay, me sitting here in front of a PowerPoint slide, oh, do you understand what your infrastructure looks like? But no, it's a really big issue. Like, when you walk in, again, you don't know how many server rooms I walked into, where I would be showing the servers I have responsibility for, and then there would be a couple more servers just sitting in the back, blinking away, and they'd be like, I don't know what that is. Like, what? Okay, yeah, that's fine. Just out of curiosity, what is that box back there? I don't know. Right? And if you don't know whether or not you're within compliance for licensing, client access licenses for Windows systems, if you do not know whether all of your systems are actually professional, again, if you're in the Windows environment, they should be the professional class systems. Whatever it's called for Windows 10 and Windows 11 at this point. They shouldn't be the home systems, right? They should actually be able to connect to the domain. Right? If you don't know all of this information, then it's going to be very difficult to build out your security infrastructure. Again, one of the big things in the Microsoft world is something called Active Directory. Active Directory is absolutely amazing. Again, the kids nowadays all love their blockchain. As excited about as those kids are about blockchain, that's how excited I am about Active Directory. Active Directory is, as the kids say, AMAZEBALLS. If you're going to have a large environment, you really should have Active Directory. But Active Directory gives you security policies for all of your users, allows you to create groups. Again, if it's built into the Windows servers that you're dealing with, you have routing, remote access services, VPN, all of this kind of amazing stuff. Here's the thing with Microsoft. Microsoft always wants to get a little bit extra money out of people. Always wants to get a little bit extra money out of everybody's pocket. And of course, most business people want to keep as much money in their pocket as possible. One of the things that Microsoft does, right, is if you get a home license for a computer, let's say it costs $100, and if you get the business class license, it costs $150, right? Or if you go to Dell, many times you'll get a computer from Dell with a home license on it, and then you have to pay an upgrade fee of $70 or $80 or $100 or something like that. The thing is that that business class license gives you the business functionality that you want. Primarily what it gives you is access to be able to connect to a domain controller and become a member of this whole Active Directory environment. So one of the issues that you're going to have is if you're trying to create security policies, if you're trying to create permissions and all this kind of stuff, and a quarter of the computers on your network are home versions of Windows, you're going to have a lot of issues. And one of the things too, again, one of the things you have to be thinking about in the security world is this is not just a technical thing that we're doing. This is also a sales thing, as we say down here. It's a bit of an art too. And we have to get other people to buy in. So if I initially do an audit, I find out that 20 systems on the network are running the home version of Windows. So I need to know they need to get upgraded. Let's say that costs $100 a piece. So if I know that's going to be an additional $2,000 simply to upgrade those computers before I start doing anything else, I can come to the CEO and I can start easing them into the idea. Okay, CEO, I'm very happy to come in and start cleaning up the infrastructure, start making sure that you have a good security environment here. One of the things that I want to warn you about first is many times businesses like yours haven't purchased the proper licensing. So one of the first things I'm going to do for you, CEO, is I'm going to audit your infrastructure and make sure that you're using the appropriate licensing for all your systems and servers. If we have to upgrade your Windows, client systems, that's probably $100 a piece plus whatever your cost is. If we have to do, if you have to buy additional client access licenses, those are the licenses that actually allow you to connect to Active Directory. I think those are $50 a piece. So depending on what's going on with the environment, it may be up to $150 for each computer that we find, are not connected to the Active Directory environment. I just want you to know that. And then you just lay it there, right? Again, one of the things you have to understand about CEOs is the faster you try to make them make a decision, the more likely they are to say, bugger the hell off. They won't say no. They know if they say no, it might come to bite them in the ass. So they'll just yell at you some weird profanities until you leave. It's kind of like a no, but not a real no. Anyways, all right, so you gotta warm them up. Part of cybersecurity is the sales process. Again, remember, Zig Ziglar used to say, you sell the sizzle, not the steak, right? You gotta warm the people up into this whole idea of budgets and costs and all that kind of thing. So if you're like, okay, these are some of the costs that we expect that you may have to pay, the CEO has that in their head. Then you go out, you do your site survey, you do your initial audit, you get all of the documentation back, you write it all up, and then you go, unfortunately, it's about what I thought, and about 20% of your systems, are using this home version for whatever else. These should have been purchased as business class systems to begin with. I wasn't part of that process, but we do need to get them up now. As I told you before, it'll be $2,000 to $3,000, and that's about where the price is, right? And so one of the big things with the initial site survey is simply going out there and starting to get an idea of what the overall environment looks like. And then, again, remember, you're dealing with a real business world. Again, a lot of IT professionals come in, and they think that the entire budget should go to them. Come on, CEOs don't have anything better to spend their money on rather than servers and data centers and all that kind of thing. Remember, when you're going to a business, the CEO has to decide whether they're going to hire a janitor or buy you a server. They have to decide whether they're going to buy a billboard or whether they're going to, equip the data center with an HVAC system, right? These are all different expenses, different amounts of money. And so one of the things too is when you go and you do your site survey and you do your initial audit, you can start seeing where all the problems are from a security perspective with your environment, and then you can start budgeting out how much it will cost to fix the particular problems, and then you can come to the CEO and basically say, okay, this is what we're looking at. The other thing to realize whenever you're doing the whole sales process is, remember, you can't do everything at once. If you walk into an environment that's absolute horse crap, even if the CEO dropped $1 million on your head tomorrow, you kind of get everything fixed tomorrow, right? Things just take time. Things take time. And so one of the things is when you do your site survey and you do your initial audit and you figure out what everything looks like, what you do is you segment all the different problems off. Okay, our firewall isn't up to snuff. We got the client access licenses here. We got the antivirus stuff here. We don't have a disaster recovery solution. We then figure out what the budgets for each one of these things should be, and then we focus on whatever we think the priority should be. Disaster recovery. When in doubt, fix your disaster recovery solution. Anyway, but then you can go and you go, okay, this is the overall thing, and the overall budget for all this is going to be $200,000. But obviously, there's only so many hours in a day. This is what I can get to. So I believe this month, this is the problem that I can fix, and the hardware, software, all of that kind of like materials cost for this particular part of the project is going to cost $20,000. The next thing that I want to get to is this one, and this one, and this one, and this one, and this one. And again, you go through that way. Again, the big thing when you're doing the site survey and the initial audit is what the hell are you actually looking at? Do you, in fact, still have Windows NT4 servers on your network? Again, this might be a big problem. We had this with doctors' offices back when I had my company, or some of these doctors' offices would have these archaic old Unix systems that were running their billing solutions. We literally had one doctor's office. Oh, I felt so bad. They had this. It was like a 12-year-old server that crashed. It was 12 years old, so there's no way in hell we're going to be able to find a motherboard for it, just not even a question. And then the hilarious part was, it was this distribution of Unix, not Linux, it was a distribution of Unix that had stopped being produced. True story. So one of the things with the initial audit and the site survey is finding out what your systems are and getting them up to speed. Verify that what you are told is true. And that's one of the big things to be thinking about with this. A lot of times when you walk into environments, again, CEOs, secretaries, everybody else, chief operations officers, they are going to tell you something, but they're not really going to know. And then one of the big things is to find out, is that in fact true, or is that incorrect? I've seen this a big problem. This is one of the big problems you see in the real corporate world, is a lot of times people think they purchased licenses they didn't. Oh yes, all of our licenses are completely up to speed. And then you get in there and all their licenses are expired. Make sure what that is. Communicate with all parties and make sure everyone is on the same page. Again, when you go out there and you do the site survey and you do the initial audit, you need to talk to everybody. You need to talk to the CEO. You need to talk to the COO. You need to talk to the warehouse workers. You need to talk to the secretaries. You need to talk to anybody who touches a computer, and make sure you really understand how they do their jobs. Again, one of the things I talked about before with this whole cybersecurity thing is the problem of shadow IT. And so basically the idea with shadow IT is that there's the normal IT infrastructure that everybody's supposed to use that's supported by the company. And then there's the IT infrastructure that the employees just started using on their own. CRM solutions, God knows what the hell they're actually using. And so one of the things that you need to do is you need to go out there and you need to talk with people and you need to verify how they're actually doing their jobs. Because if you go in and you start setting up all of these security policies and everything else, and the sales department, all of a sudden they can no longer close sales because the CRM solution that they're using is a shadow IT product, not something that you actually knew about, not even something that they're supposed to use. But just because they're not supposed to use it doesn't mean that they're not using it. All of a sudden you start shutting down ports and you start doing all those things that you're supposed to do as a good security professional, and everything kind of goes to hell in the business. Security is as much an art as it is a science. Again, there is no right way to do security. You have a budget, you have an environment, you have a user base, an employee base. They are trying to do specific things. There are specific threats that they have to worry about. You have to think about this when you create the security posture for the organization that you're going to be in. Again, when I was in Baltimore, physical security was a very important thing. A crackhead coming in and stealing your Active Directory server was like, yeah, no, seriously, that was a real thing that you had to worry about, right? Here, now that I'm in Asheville, North Carolina, one of the big problems is internet connection and that type of thing. There's different security concerns depending on where you are, and you need to be thinking about this. Good security is in the eye of the check writer. And again, this is where I talk about sales. I know a lot of people hate this. I know a lot of people cringe every time I say it. But remember, being a real IT professional, being a real cybersecurity professional, it is about relationships. Yes. It's about getting to know the other parties, right? The other vested interest in whatever the hell is going on. It's getting them to trust you. Again, they don't have to understand what you're doing. They're never going to understand what they're doing. What you're doing, they do have to understand. Basically, they do have to trust you and trust that you understand what you're doing. So one of the big things is when you do the site survey, when you do the initial audit, when you come back with a report on what should be done, basically, at the end of the day, whether or not you're going to be able to do what you need to do is based on the check writer, the person that is actually writing the checks. Will they sign off for what it is that you need? Again, one of the most asinine things I've ever seen in my life, real world, is I worked for this one company, and they were going to, or they were, I don't know how to put it, they were supposed to be creating a real disaster recovery whole infrastructure. I mean, years and years ago, like 20 years ago, right? Basically, the idea was terrorism was a concern. If somebody walks, basically, if a semi-truck drives up with a big bomb in it, their headquarters goes boom. The idea is basically that a secondary infrastructure should basically be able to come online within a couple of hours, and that the entire company should be able to keep doing what it was doing, right? Here's a real world thing. So, it's so screwed up. So I met the guy who's responsible for the disaster recovery thing, and he showed me through all the buildings. He showed me the boxes of equipment that he had, and we sat there having a lovely day discussing what he was supposed to be doing, and he had all of the time to talk to me because he was actually allowed to do what he was supposed to be doing. So the company at that time had purchased $5 million worth of hardware. They had hired this guy as a disaster recovery architect. They had the facilities and the whole 9 yards, but then at the end of the day, they simply did not allow him to set up all of his equipment. Literally, he had been working for the company for a year, and I asked him what he had done in a year, and he said, well, I ordered all the equipment, and then when all the equipment came in, I had it loaded into the server room everything was supposed to be in. And I was like, okay. And then he said about a month after that, the CEO said they needed that room for another IT project, so I by myself moved all the equipment somewhere else. And then he was like, yeah, and about last month I was told I could have the room back again. So I moved all the equipment from wherever I put it back into this room. And that's the issues that you get into the real world. And that's something that you have to be thinking about. Again, when we talk about relationships, when we talk about who that you're going to call, the whole 9 yards, it's not just about the money. It's not just about a lot of things that you're thinking about. It's that overall buy-in so that you can actually create the overall security environment that you want to create. Now, the first thing when you're thinking about layered security that you need to consider is, again, operational security. Just a class on operational physical security. Won't go into this a lot, but basically the idea with operational security is securing how your organization runs. Again, if somebody wants to come after your infrastructure, if they do not know whether you use AWS, Azure, some type of internal infrastructure or whatever else, it is going to make things a hell of a lot more difficult for them to come after your infrastructure. If they're trying to compromise your databases or whatever else, and they have no idea what kind of databases that you're actually using, that's going to be a hell of a lot harder to try to compromise your infrastructure. Again, if somebody walks into your building intent on trying to plug something into, a networking closet or something like that, and they have no idea where the networking closets are, then it's going to make their life a hell of a lot more difficult. Again, Aaron Swartz, who was basically given the death penalty by the U.S. government, what was it, Harvard? It was like Harvard or something, Harvard or Princeton. He went into a networking closet. He plugged in a laptop computer in order to harvest all of this research information that was supposed to be open, but it was behind a paywall, whatever else. The government went after him, was trying to convict him and throw him in prison for 30 years, and he decided to kill himself instead of having that happen. One of the things to be thinking about, though, is that he knew where that networking closet was, right? That's operational security. If you know where a vulnerability is, it makes it a hell of a lot easier to go after that vulnerability. If you do not know where the vulnerability is, it makes it a lot more difficult. Again, things to be thinking about, like with your offices, depending on what kind of company that you're going to be having, is thinking about putting your offices in a nondescript high-rise office building, right? A lot of people, especially a lot of businesses, they want to put their signs everywhere. The CEO wants everybody to know that their corporation is moving up in the world, and this is exactly where our headquarters building is. That's basically putting a target on your building and saying this is where we are if you want to try to compromise us. Something to think about is if you put your offices in some nondescript office space somewhere, you don't put up any fancy signs, you don't have any arrows pointing to where you are, it makes it more difficult for hackers or any kind of attacker to come after you. Again, physical security. Once somebody figures out where you are, and so they're trying to go after your vulnerability, basic things with physical security is locks, doors, walls. Again, doors. Oh, Remember the days when offices used to have doors? I don't know, in the modern world there's this whole thing about like open offices. I don't do it. Open offices are kind of horrible to me. I mean, I don't know, it seems like there should be like a middle ground, like, hey, let's have some closed offices and let's have some open office space. I don't know. The younger generations, they always go too far one way, right? But again, something to think about with physical security is if somebody does walk into your building, how far can they go before they're blocked with doors? Again, when I was in the corporate world, everything was divided with these little doors with electronic locks. So again, if you want to get into the legal department, if you want to get into the HR department, anything like that, there was a lock, right? So if you couldn't swipe through and get through that lock, you were not allowed to go into that area. That is another layer of security. Again, basic things like walls. Remember, when you have somebody that can walk into your environment and you have an open office space and they can survey your entire environment, then they can understand what is going on with your entire environment, and then they can try to compromise your systems based off of what they see. Simply having walls, you walk in and there's walls, you can't see what's on the other side of the wall, so you literally don't know what's on the other side of the wall. So that's a form of security. Once you actually start getting to the technology components of security, the most important thing, probably one of the first things that you need to start figuring out for your infrastructure is patch management. So all patch management is updating your damn software. So your operating system software, your Office software, your Quickbooks software, also things like Java. So a big problem that we had back when I had my business is that the hackers were going after old Java at the time. So you install Java onto your computer, and then once you've installed Java onto your computer, you can run Java apps. The thing is, Java was like really popular. Like back in like 2000, everybody thought Java was going to take over the world. Java. Code once, deploy anywhere. We heard that before. Anyways, that was the idea with Java. It was a great idea. Great idea. Java was a bit buggy. Java didn't quite live up to expectations. So the thing is, everybody installed Java onto their systems and then forgot about it because it was a pain in the ass. The Java apps didn't work how they were supposed to, so everybody started coding their apps in something else. And then basically you had a lot of these systems that might have been around for 5 or 6 years. Somebody had installed Java on it at some point in the past and then forgotten about it because they never used it again, and therefore it hadn't gotten updated ever. And so you actually had hackers that were then going after and trying to compromise these old versions of Java, right? So old versions of software, it is highly documented what their vulnerabilities are. So why go after zero-day attacks? Why try to attack systems based off of vulnerabilities nobody knows about, when you can simply try to attack systems based off of vulnerabilities that are well documented, and all you have to do is go after folks that haven't updated whatever things that you're going after. So you think about Java, you think about Adobe, you think about QuickBooks, maybe think about Chrome. Again, any kind of software beyond just the operating system is something that you have to be thinking about. So you have the OS software, firmware and computer servers, and again, one of the big things to be thinking about in the modern world when you start thinking about patch management is your devices. This is nasty. This is nasty. Oh, I thought BYOD was bad back in the day. BYOD, you're gonna bring your own device onto my internal infrastructure? Oh, hell no, that's a horrible idea. You know what's even worse than BYOD? IoT without a plan, Internet of Things. All of your surveillance cameras, all of your new fancy access control systems, your time card system, whatever the hell you use for your hourly workers to punch in and punch out. All of that kind of stuff now is IP addressable, basically has Linux servers built into them, the whole 9 yards. And the interesting thing about most of those devices is that there's no ongoing care plan for most of the vendors. Most vendors, when they sell you an IoT device, they give you that device and then they're done. They walk away. They're not going to upgrade the firmware. They're not going to upgrade the operating system and all the other little components on that device. They sold you a device. They're done. The issue is remember, with all those little IoT devices, essentially what they're doing is they're running Linux. They're running some distribution of Linux. Linux, just like everything else in the technology world, has its vulnerabilities, whether they're known about or not. And so one of the problems that we run into in the real world is that these devices are created with some version of Linux, a year or two from now, hackers figure out a vulnerability with that version of Linux, and then you now have, 10, 20, 500 of these highly vulnerable devices within your infrastructure, and the vendor has no plans for upgrading, trying to fix the vulnerabilities or whatever else. So you need to be thinking about that again if you have access cameras. Again, and that's one thing to be thinking about when you purchase equipment, especially IoT equipment, when you're going to purchase things like digital surveillance cameras. One surveillance camera off of eBay may cost you $20, and AXIS surveillance camera may cost you $150. Oh, why am I gonna get ripped off when I get the exact same quality product for only $20? Only an Apple sheeple would buy an AXIS camera for $150. The reason is Axis is actually a reputable company, and they will actually, put out upgrades and updates and all that type of stuff for their equipment for a decent amount of time. And the other thing to be thinking about too, again, whether it's Axis cameras or D-Link cameras or anything like that, is you do have to be thinking about how long are they going to continue putting out updates for their equipment, and how are you going to update the patches and all that kind of thing. One of the big things that's nice nowadays is that they have patch management solutions. So back in the day, back when I had my store, patch management sucked. You had to go and update everything on everybody's computers. They just come out with like Windows update services. WSUS, I guess it was called. That was nice. That would actually update at least update all of the Windows computers on your network that were within Active Directory to all of the latest stuff for Windows. But the problem you ran into is, what about Adobe and Quickbooks and all that kind of thing? Now there's a lot of different patch management solutions out there. So I just did a screenshot of Manage Engine, automate patching for over 850 apps, including Windows, Mac, Linux, and third-party applications. So you go, you buy this particular product, and hopefully that will help do the patch management for your infrastructure. One of the things I will warn you about with patch management, though, is notice that they don't say all, do they? They don't say all apps will get will get patch management. They say over 850 apps, including Windows, Mac, Linux, and all that kind of thing. The important thing with these patch management solutions is basically they build these solutions, and they have to basically configure every single type of software, every single kind of app that they're going to upgrade for. And so again, if you have some kind of random thing, if your company is using some type of software that's not within their patch management solution, you're going to have to make sure that gets upgraded on its own. Again, that's where we go back and we start talking. We talk about talking to everybody, creating relationships from the secretaries to the CEO, making sure you understand what everybody uses, and making sure you have that list, document the list of all of the different programs that your company uses, and then match that to the patch management solution to verify that the patch management solution will actually update everything that you need updated. Past that, we get to software privileges. So this is one thing that confuses a lot of people. There's software privileges, there are security policies, and then there's sharing permissions. These are different things. The reason we're having all of the ransomware attacks that we are currently having in the modern world is because the administrators don't seem to know the difference between these things. And so basically, they deal with software privileges, but there's a problem with the sharing permission, and therefore, basically, you can have a database that's completely locked down. If anybody tries to log into the database itself, they will be blocked, because the administrator made sure that all of the privileges within that database are restricted to the appropriate users. Here's a problem. The database file is sitting in a folder where the administrator forgot to lock down the sharing permissions to that particular folder, and any jackass can, delete, copy, encrypt, whatever else, the database itself. Again, this is one thing where you have to visualize what is actually going on when we think about security. And so when you enter a database the normal way, that's basically logging into the database. And so when you log into the database, based off of your credentials, you get so many privileges. That's one way to interact with the database. The other thing to be thinking about is that database is it is a file. It's a big ass file. It's sitting somewhere. And so if you want to be nefarious, if you're able to get to that database file from an alternate route, basically come in through some kind of shared permissions into that folder, and then again copy, encrypt, whatever else, That's where you can run into some issues. So basically with software privileges, this is for things like databases. MySQL database has software privileges. Quickbooks has software privileges. We think about calendar software, CRM solutions, all of that kind of stuff. Basically, the idea here is you have you have however many people that can actually manage the account, and then you want to give access to other people to read and do specific things, right? So if I have a calendar, I am able to do everything I want in the calendar. I will give I will give my secretary the ability to read what is on the calendar, so that if she's trying to set up an appointment or they're trying to set up an appointment, that they know what my free time slots are, right? Basically, software privileges keep people from modifying records or allow them to modify records, and we're talking about accounts within QuickBooks, within database apps, that type of thing. This is privileges within the applications themselves. Then you get to security policies. So what security policy is, this is OS level security, and generally when we're talking about security policies, we're talking about Microsoft Active Directory. Have I told you how amazing Active Directory is? It's so nice. It's so nice. If you have not used Active Directory, you should. Go out. Don't spend that money on a Bitcoin. Spend that money on some cows for Active Directory. Anyways, every time I make a joke like that, it really irritates a lot of the younger people. I'm sorry cryptocurrencies are stupid. It's not my fault. Anywho. So basically when we talk about security policies, we're talking about OS level security. So again, this is basically Active Directory, which is absolutely amazeballs. When you go into Active Directory, you're able to create these things called group policies and security policies, and they allow you to do a lot of, basically configure a lot of security for computers and allow you to say what users can or cannot do. Are they allowed to install software onto the computer? The answer should be no. The answer is no, correct? But beyond that, like a lot of times we talk about security policies is, whether people are able to change the background on their desktop. Are they able to change fonts? Are they able to install applications? Are they able to map network drives? All that kind of stuff. What's also interesting is things like access to stuff such as USB ports. So again, when we talk about physical security, even with physical security, in order to get to an end result, there might be multiple ways of getting there. So I've talked about that before, where if a hacker actually gets into your physical facility, one of the big vulnerabilities is the USB port. Right? If they're able to boot a computer off of a USB live thumb drive, basically, something like a Kali Linux drive, they might be able to boot off of that and then be able to access all of the files inside the computer, right? USB has a lot of vulnerabilities, can be used for key logging software, all kinds of different things. So if you want to protect your USB connections, there's multiple ways of doing it. From a purely physical way, one of the ways to do it is there's these little USB locks. Ridiculously expensive, idiotically expensive. Must be made out of gold, these things. Anyways, there's these little USB locks I showed you in one of the previous classes. Basically, you can put these things into the USB ports, and that physically blocks the USB port if somebody tries to plug a USB drive into the USB port. Or you can basically use the good old-fashioned rubber cement. I've heard people use rubber cement. Don't sue me if that goes poorly, but right, that's a physical way to block the USB drives. Then beyond that, one of the things to be thinking about is going into BIOS and preventing people from booting from the USB. So within BIOS, you can set what the boot order is for the computer, and beyond what the boot order is for the computer, you can also many times set whether or not the USB connections are active or not. So again, if you want to lock down the computer, again, make sure that the USB is pretty blocked off. You can go into BIOS and block those USB connections. One of the other things you can do is, again, within security policies, within Windows Active Directory, you can go in and you can basically say that these specific users are not able to use the USB ports. Again, if you're worried, you think about the different vectors for attack, and so somebody picks up a USB drive off of the ground and they plug it into their computer, it has an auto executable on that USB drive to try to infect the system, right? If they plug it into the computer and then it fails out for any number of reasons, that is a way that you have protected your systems, right? If you block the USB connections, you block from a hacker being able to boot up off of a live operating system and then try to compromise your systems. you block somebody, basically trying to auto install something when they plug in a USB drive. You block the employees. Again, the employees, they come in, they have a thumb drive that maybe their kid was using when they were looking at porn sites. They don't think about it. They take that exact same dirty, nasty, disgusting thumb drive and they plug it into your internal system. If the USB connections are not configured to actually work for them, that solves the problem, right? You don't have a vulnerability there. And so security policies are really amazing. And again, if you run an infrastructure where you're not using Active Directory, you should really think about Active Directory. Beyond the security policies, you then get to sharing permissions. So again, if you ever go for the MCSE program, I guess the MCSE doesn't really exist anymore. But with that, when you go get Windows certified, this is something they're going to hammer you on tests, like the difference between security and permissions, and then gets all stupid, right? But anyways, basically what sharing permissions are is when somebody tries to access a file or folder or resource over the network, what permissions do they have? Basically in the Linux world, it's like read, write, execute. So can they read, can they write, or can they execute? So do you have permissions to delete the folder that contains the database that you don't have permission to log into? And so this is a very important thing to be thinking about. If you have a file server and you have a whole bunch of folders under that file server, making sure that the permissions are configured properly for everybody so that some random warehouse worker is not able to delete the HR folder. Oh, you're about to I'm about to get terminated. And the reason I'm about to get terminated is because they've written me up 2 times previously, so if I get written up for the 3rd time I get fired. Well, if I just delete the folder that has all the write-ups in it, how are they going to prove that I'm getting written up for the 3rd time? Things to think about there. Something to think about with passwords. So again, passwords are going to be your access to all of your computer systems. So what is your password policy, and do you use something called multi-factor authentication? One of the big things that I would say, and this is one of the big problems with administrators, again, everybody likes to laugh at users. Stupid users! One of the points that I try to make in these classes, even though it sounds obnoxious as hell, again, you are all employees to me. And I know I get a lot of people frustrated with that. But again, being the owner of a business, having actually owned a business with employees, one of the most amusing things is like employees think managers and owners are like somehow in the same peer group, and it's not so. It's like they look up and they think like all the right. The reality is everybody does stupid crap. When you're the owner of a company and it's not just what your employees are doing, it's what your managers are doing, it's what your system administrators are doing. It's just like, what is wrong with these people? And so one of the big things to be thinking about is, again, with your global domain administrators, or whatever the hell they're called nowadays, is are they logging in with global domain administrator permissions, security policies, in order to check their email? I'm going to tell you the answer. Yes, they are. We all know it. Don't lie. And so the big problem is, and again, this is one of the problems with arrogance, one of the problems with kind of like that bigotry towards users, is there's this idea that somehow because you've got a fancy ass certificate, you're somehow more secure than that high school dropout who's using the computer. So of course you have to lock them down because they're lowly users while you are the superior or whatever. Again, if administrators were as superior as they think they are, we would not be having the problem with ransomware attacks right now. Every single ransomware attack I have heard about at this point in time sounds like, my opinion, it comes down to piss poor administration. But anyways, one of the big issues, right? So if you're a senior level, you're the CTO, you're the sysadmin for this company, somebody decides to do a spear phishing attack against you because you put all of your information onto LinkedIn, because that was such a smart idea in the modern world, right? They spear phish attack you, they send you some kind of link that you actually think is legitimate, you click on that link, you are logged in with the global domain administrator account, all of a sudden, scripts start firing off, with your permissions, with your privileges, with your security policies. What happens at that point? Again, if you double click on some kind of script or you trigger some kind of script that basically goes out there and tries to encrypt everything that it can find, and your security allows you to encrypt whatever the hell it is that you can see, then that's exactly what's going to happen. So one of the big things is make sure when you're using accounts with the proper policies and permissions for that type of an account. When you are logging into your email, you are as much a user as any other user on the network. If you are able to double click on a link and fire off scripts, you need to punish yourself. Something about the passwords is expiration time period for things like passwords. Again, a lot of people don't like passwords expiring, but one of the big problems in the corporate world is that people learn other people's passwords. Again, passwords get shared around, right? You know, I'm the COO, I'm some executive, you know, I have a secretary, I'm having some kind of problems with my systems, so I give the secretary my username and password. Again, this is something that normally happens. It should have happened? Absolutely not. Is it going to happen? Absolutely. But one of the big problems is you hand over that information, and if the passwords don't have any kind of expiration, then that password is going to continue existing forever and ever and ever and ever. I think about this with the example that I brought up a number of times. There was a PR person, and so the PR person left one company, went to a different company. Then, while they worked at the different company, they realized their credentials still worked at the first company, and so basically they were just spying and doing all kinds of espionage on what the first company was doing and handing all that information over to the second company. They got arrested and all kinds of nasty stuff happened after that. But something to be thinking about, again, one of the things a lot of folks don't think about is what happens when the CEO hands their username and password over to their secretary. Their secretary leaves, quits, fires, gets terminated, whatever else. And that information is scribbled on a paper, right? If it's a CEO username and password, that's most likely going to have VPN access. That's most likely, again, going to have access to the email services, all that kind of thing. And so if that secretary leaves, what happens if that secretary gets pissed off about 3 months down the pike and decides, wait a minute, gosh darn it, realizes that those credentials still allow that person to log into the system as the CEO, what kind of havoc can ensue at that point? If you don't have any kind of password expiration policy, that is something that can legitimately happen. Again, password reuse. If you have password expiration times, but then you allow password reuse, people are just going to keep using the same damn password. So stop that. And then the whole idea of password complexity. How complex does a password have to be? One of the big things to be thinking about is, again, if people can overhear what your password is. If your password is password, my password is password. And I tell that to somebody for whatever reason, because that's what's actually going to happen. If other people can hear what your password is, then they can scribble it down for their own notes and have it ensue at other periods of time. If you have some ridiculously complex password, even if you do tell it to somebody else, people aren't most likely going to be able to remember it very easily. Again, the idea is how easy is it for people to remember? If it's highly complex, then they're not going to be able to remember it, therefore it gives a little bit more security. Now, I think about this when I had clients, some of my old-time clients, I go back to them again and again. And one of the interesting things is, after I went to a client a couple of times, I just sit down at their computer, I would log in, I'd be doing the stuff, and it was funny, like 10 minutes later, the person would come in and be like, oh, I forgot to give you my password. And I'd look at them and be like, I already know your password, I memorized it. I've already been here twice, I know what your passwords are. Right? Because they're not complex, they're relatively easy to remember. It's like, oh, this person uses this type of password with a 1 at the end. When you start thinking about things like antivirus, anti-malware, anti-spyware, one of the big things to remember with all this kind of stuff is these are different products for some reason. There's antivirus, and there's anti-malware, and there's anti-spyware. A lot of products you're going to buy, these are separated out into different things. Find a product that actually supports everything that you need to try to eliminate. Verify that whatever you're using actually does what you think it does. Again, this is one of the things with malware, spyware, and antivirus solutions. Some of the solutions out there, they protect from viruses, but not from malware. Malware and spyware. What? I don't understand. You know what the hell we mean. So anyways, right, it's a way for the security software companies to upsell their products. Oh, you want viruses? Well, that'll be $50 a year. Oh, you want malware? That's an extra $10 a year. Oh, you want anti-spyware? That'll be an extra $10 a year, so it's $70 a year. So instead of just charging $70 a year and giving a full feature package, they initially sell you on the idea of the $50 a year package, but don't give you the stuff that you would assume would be there. And this can be a real problem with CEOs. Again, CEO goes out, they do their own research. Well, IT person, I did my own research, and I don't know where you're coming up with this $70 per year license thing. I read right here that it's $50 per year, so that's all we're gonna pay. It's like, yeah, but it's $50. That's only for antivirus. We also need the anti-malware. We also need the anti-spyware. We also need a couple of these other things, so we need to pay that $70 or $80 per year. Anyway, so make sure your solution does what it actually needs to do. Again, one of the big things in the modern world is make sure that it's able to be centrally managed. If you're dealing with an enterprise type environment, you want centralized management. You got 100, you got 1,000 computers, all doing whatever the hell 1,000 computers are going to do, especially with remote workers and the whole 9 yards. You want to be able to make sure that the software has been automatically updated. You want to make sure to be able to see what the update status of your antivirus solutions are. You want to make sure that they are doing real-time scanning, that they are doing a complete scan at least once a week. You want to see what the results are. Are certain people getting more viruses than other people? Is that something that you have to look at? The whole 9 yards. You need central management in order to be able to deal with that. Proper licensing. Oh God. The horrors! I'm starting to get PTSD flashbacks from doing this particular show. Oh God, proper licensing. Again, one of the big issues you deal with in the modern world is you have one product, more or less, you have one product that does something, and then there's like 3 different licenses for more or less the exact same product, right? There's the free license, then there's like the home user license, and then maybe there's a business or enterprise class license. And again, CEOs or whatever, they're gonna focus on the free. Look, it's free. Problem you run into is a lot of times like the free software is not licensed for commercial use. Again, you as a professional, one of your jobs is to protect your company, protect your infrastructure from all possible harms. Using improperly licensed software is as much a possible harm as a lot of this other stuff. So, if you have a bunch of free Avast or AVG, whatever the cool free antivirus software solution is nowadays, you might run into a problem because that may be licensed only for home use or only for small business use, up to 10 users or something like that. So you need to make sure that you actually have the proper licenses and that you're paying for the proper licenses. Again, that's going to be painful for some companies. If you have a 50-person company, they've all been using free antivirus for the past decade, you come in and say, no, we need to be spending $50 a year per computer. And what is that, $2,500 a year that the boss wasn't expecting to have to pay, but they do need to pay that. The other thing to be thinking about with your antivirus solution is it scalable to the degree that you need it to scale to? Again, with whatever business that you're going to be in, if you're in a startup company and you plan to go to the moon, then whatever antivirus solution that you're going to be using, you need to be able to scale to the moon. Again, that's one of the problems when we look at like the cost of some of these products, right? Some of these products might only be $5 a year, $10 a year free or something like that, but they don't scale, right? Again, as long as you have less than 10 users, fine, whatever, they work fine. But as soon as you need central management, as soon as you need real log files, as soon as you need control, as soon as you start needing a lot of this other stuff, the reality is the security software that you're using simply doesn't scale the way that you need it to scale. And so that's one of the things, again, when you do that initial site survey, when you do that audit, when you sit down and you talk with all parties, that's one of the things you need to ask is, what is this company going to look like in a year, 2 years, 5 years, right? Because if the company that you're at, let's say, has 50 employees, and in 5 years is probably going to have 55 employees, then just use whatever antivirus solution you're using, right? If the antivirus solution you're using is working fine, cool, stick with it. If not, find a new one. But one of the things you have to look at is if you have 50 employees and the person's like, I want to be to 1,000 in 2 years, the solution that you're going to need, the antivirus solution that you're going to need, is going to be much different. So it might be better to pay a much higher cost enterprise class license, even when you only have 20 users, right? 20 users, why are you using enterprise software? Because I am not focused on the 20 users that we currently have. I am focused on the 1,000 users I'm told we're going to have in 2 years. Spending a couple of extra dollars now in order to just have a seamless, scaling curve is going to make life a hell of a lot easier. And then standardization. Oh golly, again, the business world. Oh, the nightmares. Can you see the sweats? I'm starting to sweat. Oh, standardization of antivirus. Bugger me. Here's the thing, antivirus is just like every other software. It's all quirky. It's all quirky. All technology is quirky. Apple computers. I love Apple. Apple has problems. Every time I talk about Apple having a problem, all those little trolls out there are like, oh, I thought Apple was perfect. No computer system is perfect. They just have more or less problems. The quirks are easier or harder to deal with. Same thing is true with antivirus, anti-malware, anti-spyware. This is all just simply a technology product. All technology products have their own quirks. One of the problems you can have, again, in the real world is especially like a lot of times when companies buy laptop computers or computers, they come with a year or 2 years or 3 years, whatever freaking crappy antivirus somebody was willing to pay Dell to put on a system. So sometimes it's Norton, sometimes it's McAfee, sometimes it's Kaspersky, sometimes it's Trend Micro. Again, one of these companies comes in, and they throw a lot of money at the people that are selling the computers, and they install a couple of years of this software for free or for a relatively low cost. And so this seems good for the CEOs, it seems good for the executives, because okay, we don't have to pay anything additional for antivirus. The issue is all of these solutions are quirky. Trend Micro is quirky, Kaspersky is quirky, McAfee, do not touch McAfee. Do remember, whenever I talk about McAfee, I talk about McAfee from like 10 plus years ago, a long time ago. Do not touch McAfee. Norton is quirky as hell. Anyways. Some of the problems you can have, again, when you're trying to go out there and you're trying to support the computers and make sure everything is up to snuff, is if the computers within your environment have 5 different types of antivirus software on them, possibly with different levels of security, basically different versions, that can just become an absolute nightmare for trying to figure out, what is the security of your actual environment. So whenever you're going to come up with your antivirus solution, it needs to be standardized. Every single computer that comes into your environment, it gets this. Again, as long as it's not McAfee, I don't care. Even Norton. Norton's not. Symantec. I guess Symantec is the corporate version. Symantec's actually not too bad. Norton I'm not going to go into. Symantec's not too bad. But anyways, you just standardize on that. Then everybody has the exact same security software on their systems. You make sure it's all configured properly. You make sure it's all going back to that central management. You're getting logs and all that kind of stuff. It's going to make your life a hell of a lot easier. Then we get to firewalls. Oh, firewalls. I love firewalls. Firewalls have made me so much money. Not for good reasons. Not for good reasons. Firewalls have made me so much money because back in the day, people would configure firewalls not knowing really what the hell they were doing, and then basically they would lock down their entire network, and they'd have to call me to unlock their entire network. Big thing to understand about firewalls, again, basically firewalls are closing TCP ports. So we talk about ports. All networking services use a port. FTP uses port 80. I'm sorry. HTTP uses port 80, SSL uses port 443, FTP uses a port, STMP uses a port. All these other ones use ports. It's been a while, I forget all the port numbers. Anyways, so basically the idea is with firewalls, they shut down ports, or they only allow certain communication to come through on ports. So basically you could create a web server on your internal network and then set up a firewall so that only local computers are able to access that web server on port 80. That's what firewalls do. One of the big things with firewalls is make sure you don't break something. One of the big problems we get to in the real world of networking is there is a hell of a lot of undocumented port usage. Back when I was younger, I liked firewalls a lot more than I do nowadays. Because basically what I figured is like, well, there's all these products out there, but obviously they have to document what ports they use. And so all I need to do is I need to go talk to all the people that have any say in what's going on. I have to document all of the products that we're using. I will then simply go to the research. I'll simply write down all of the ports that all of the equipment is using. I will open up those particular ports, configure everything properly, and yay, it'll be wonderful. Oh my golly, especially with things like surveillance systems, access control systems, especially like weird companies that you probably never heard of before. They don't necessarily document their port usage. And so you can break a lot of stuff. So one of the big things you have to be thinking about, if you're going to be using ports or you're going to be using firewalls, is make sure you don't break anything. And so if you're going to be setting up firewalls, again, we go back to communication, we go back to relationships, we go back to talking to CEOs and the secretaries and the warehouse people and all that. If you set up firewalls, as soon as you set up the firewall, make sure you go around and you start talking to everybody in the office and making sure everything is working how it's supposed to. Again, I saw this before with one of my clients where their systems were all locked down. They had a good cybersecurity person come in, lock down their systems to the point that they couldn't do what they needed to do in real world. And again, one of the weird things was the CEO was like a day trader. Well, not quite a day trader, but basically he made a chunk of money investing on the side. And so he had this Merrill Lynch software that was on his computer. And basically when all the ports were locked down, that Merrill Lynch software needed some random ass port. I could never figure out what port it actually needed. And basically the previous person had blocked that port. The previous consultant had blocked that port, so this person was no longer able to trade stocks while he was in his office, which caused him a lot of problems. Again, his systems were so secure that he wasn't able to do what brought money in. Careful of that. Again, make sure you understand your environment. And the other thing to be thinking about with firewalls is, should you use a firewall or turn off server services? Again, the whole idea is, should SSH even be available? I think this is one of those big things to be thinking about in the modern world. A lot of times we try to throw, the whole idea is, if you have a hammer, everything looks like a nail. A lot of times we get hyper focused on whatever product we like. Again, firewalls. That's just something that everybody likes to talk about. We need a firewall. Again, something to be considering is, do you really need all these firewalls, or do you need to go through and start cleaning up a lot of the services that you have running on your internal network? If you actually shut off a lot of the services, you may actually have a lot more security rather than implementing a crap ton of firewalls. Again, when we start talking about things like firewalls and all that kind of stuff, one of the things to consider is layered networking. We have a big problem in the modern world with this whole idea of convergence. Again, talked about this before. Essentially with converged networks, we have everything running on one network. So back in the old days, telephone systems used their own infrastructure. They used something called Cat3 cable with PBXs. Surveillance systems used coax cable, and they went back to digital video recorders. Access control systems used low voltage cables, blah, 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 right? 15 years ago, we came into the converged world, and so the idea is, hey, all of these different devices, why don't we run them off of Cat5, use Ethernet, use TCP/IP, and now everything can use the exact same network. Yay! There can't be any problems with that now, can there? But the problem is when everything is running on the exact same network, that means any one device on that network can cause havoc for everything else. I think about this, again, having done digital surveillance systems, especially back when high definition digital surveillance systems were becoming the big thing, right? Every single camera could do, 10 megapixel video. Well, the problem is when you have 10-100 switches, you plug in a couple of 10 megapixel surveillance cameras, and then you start pumping back high definition video, like real time high definition video back to the DVR. The problem you can run into is basically that takes up all of the bandwidth for the entire network. All of a sudden, voice over IP calls aren't working. All of a sudden, even email services are acting slow as hell. The reason is because the cameras are taking up all of the bandwidth. Right, there's a lot of problems when you have all of your devices on one network. If any one device gets compromised, if any one device is misconfigured for some reason, it can just cause havoc for everybody. So think about things such as basically creating what I call parallel networks. Basically, parallel networks are the surveillance system is on one network, so it's on one subnet, so 192.168.2.x. The computers are on 192.168.1.x. Your access control system is on 192.168.3.x. Basically put them on their entirely different subnets and then connect them with routers. So if I need to access the telephone systems from the PC network, I can do that, but they are actually segregated off in their known networks. Something to be thinking about. One of the things to be considered in the modern world is siloing servers. So again, one of the things to consider is a lot of times we're not building infrastructure based off of the technology of today. We're building infrastructure off of the technology of 15 years ago. Again, a big issue that you're going to run into in the technology world is there are some people out there that got their MCSEs 20 years ago, and They haven't really modified what they're doing since. And so, yeah, if you went out there and you were building infrastructure 20 years ago, routers were expensive, switches were expensive, high-quality firewalls were expensive. Equipment was expensive. A server was going to cost you $5,000. So when servers are going to cost you $5,000 and switches are going to cost you $2,000 and routers are going to cost you a couple $1,000s, you build your infrastructure, again, based off of your resources. You have $20,000 to build your network and your server services, and so you're going to build it in a certain way. And so a lot of environments are built with very flat architectures simply because of cost back in the day, right? I'm not going to put all of these different servers behind firewalls because each firewall that I have is going to cost me an extra $1,000, plus I'm going to need a switch on the other side, plus I'm going to need to do a lot of other things, right? So you have these flat infrastructures where you have the FTP server and the database server and the Active Directory server and the email server, and they can all see each other and they can all ping each other, and somebody is able to compromise one, they can probably get over and compromise the others, the whole 9 yards. Something if you're thinking about in the modern world is we can silo off these different types of servers into their own little worlds and then only allow folks to be able to access them the ways that we want them to be able to access. So imagine you have a database server or a database cluster. So we have MySQL cluster, whatever the hell else you want to use. And so you have a nice little MySQL cluster, they're doing the replications and the whole 9 yards. Something to be thinking about is put that cluster behind a firewall. So basically you have a firewall and then you have a switch to connect to the cluster. And then on that firewall, you say only local traffic on these specific ports are able to access those database servers. That way, even if a system gets compromised on a local network and tries to SSH in to one of the servers in the cluster, it's going to fail out because that firewall doesn't allow SSH to get in. It only allows the specific ports. Again, we start thinking about things like different subnets and all that kind of thing. If you have some kind of web server infrastructure using IIS or Apache or Nginx or whatever else, you're using that as the front end. That front end, again, connects back to your database cluster. Basically, you can configure the firewall only these specific IP addresses are able to access these specific IP addresses over in the cluster. If anybody else tries to access those database servers, it's just going to fail out. Subnet logical business units or physical locations. Again, somebody be thinking about it. Like when we talk about this layered networking, right? So, I sneak in, I got my little Raspberry Pi, because everybody has Raspberry Pis nowadays, and I plug it into the network and I run my Nmap. Because apparently Nmap is hacked. I've been watching these like YouTube hacking videos. I'm trying to get cool on YouTube. Everybody seems so scared of Nmap. No! Don't run Nmap against my infrastructure, no! Anyways, I find it funny. But, here's one of the things to think about. If you sneak in and you're able to plug in your Raspberry Pi and you're able to run Nmap, right? Nmap is only going to be able to see whatever is in the local area network, right? And so something to consider is if you've siloed off, you have all of these different subnets that are then connected to routers. Even if somebody comes in and they try to audit your network, basically do network mapping or whatever else, they're only going to be able to see whatever computers are on that particular subnet. So if somebody comes in, they're able to compromise your network, plug in a Raspberry Pi with Nmap, and they scan, right? If your Active Directory servers, if your email servers and all that kind of stuff aren't actually on the local area network, that is a layer of protection for those servers, right? If some local computer is compromised with some kind of virus or some kind of remote access tool, if that local computer cannot easily see a good target, again, Active Directory server, email server, that type of thing, that is a form of security. So something to be thinking about. Parallel networking, and then understand how VLANs work and vulnerabilities in your equipment. So this is interesting. I need to go do a little bit more research on VLANs. I know what VLANs are, but as far as hacking is concerned, depending on how your equipment works, VLANs can actually be hacked. So what VLANs are is they're virtual LANs. So the idea, it's in the old days, old days, right? Old equipment. If you wanted to create different networks, essentially with different subnets, you would have to use different physical switches, right? So this switch would be for the 192.168.2.x subnet. This switch would be for the 192.168.1.x subnet, right? So basically, each subnet had to have its own physical equipment. Great for security, phenomenal for security. Piss poor from a cost perspective. Right, because all kinds of different, and again, from an implementation perspective, the whole nine yards can be a bit of a pain in the butt. So basically, Cisco and the rest of the companies came up with this idea of VLAN. So the idea with the VLAN is you could have one switch, and then that switch, you can configure the different ports to be on different VLANs. And so the idea is that they are supposed to be segregated networks. So this would be VLAN number 1, so you could use this for 192.168.1.x. This would be for VLAN number 2, it could be used for 192.168.2.x. This could be VLAN number 3, VLAN number 4, VLAN number 10, the whole 9 yards. So the idea is you could create all of these VLANs for your infrastructure. One VLAN for your surveillance system, one VLAN for your PCs, one VLAN for your voice over IP, another VLAN for something else. You can configure that within your switches, and then all of these devices are supposed to be segregated from each other, and the only way that they're supposed to be able to communicate with each other is through a router, right? So if you have two VLANs on the same switch, literally, if you wanted those networks to be able to communicate with each other, those VLANs to be able to communicate with each other, you'd actually have to plug in a physical router. That's how it used to be. One of the interesting things, and again, I've watched some stuff on it, it's kind of curious with coding and everything else, is that there are ways to compromise those VLANs when those VLANs are on one piece of equipment. There are ways to compromise those VLANs, and so it's just something to consider. We will probably have a class later after I do a little bit more research on this, because this is actually kind of interesting here. But just realize if you have VLANs set up in your environment, make sure you understand how the configurations of those VLANs actually work and any kind of possible security problems, because they can be compromised. Services. So again, something to be thinking about on your network is what services are available on your network, so what services can be compromised or possibly attacked. Again, things like services, FTP, HTTP, or VPN services. One of the big things to be considering within your infrastructure is how many web servers do you have running in your environment, right? You should probably have a couple. You should have a couple of web servers that you know about and that you deal with every day. But I'm going to most likely tell you, if you do that whole auditing thing, you're going to find like 10 other web servers that are just there for some reason. For some reason, somebody decided to set up IIS and then forgot about it, right? Remember, things like web servers can be massive vulnerabilities, so you want to shut those types of things down. Understand why they're FTP servers, understand why they're web servers, understand why they're VPN servers, and the whole 9 yards, and try to shut those things down, understand what the vulnerability is. Then one of the things you also need to be thinking about as far as services go are things like the administrative services. Simple network management protocol, absolutely awesome if configured properly. Snmp. The only thing that comes anywhere close to Active Directory, as far as I'm concerned, is good old Snmp. That's a sexy service there. It's really kind of cool. You put these, you put agents onto all of your devices. It can measure things like CPU temperature, disk usage, almost anything you want on a computer. There's these things called traps. Basically, when everything goes above thresholds, that can be sent back to a management console, and you can get a really good idea of what's going on in your environment. So if one of your 200 physical servers is overheating by 10 degrees, you can get an SNMP a notification about that before that server fails, so that you can pull it offline in a reasonable way, figure out what the hell's going on, and get it back up and running. SNMP is absolutely awesome. But it can be a massive vulnerability, right? If you haven't set up the agents properly, if you haven't set up the security for SNMP properly, you can have problems there. Icmp. This is an interesting one. So this is for the messaging protocol, like when you do pings, when you do trace routes, you actually use SNMP, or ICMP, too many words here. Use ICMP. This is part of the TCP/IP protocol suite. So one of the things you need to be thinking about is if somebody comes in and uses Nmap against your infrastructure, those nasty Zimbabwean hackers comes after your infrastructure. Do you want your devices to be able to respond with an echo? All right. So if somebody says pings, I'm going to ping 192.168.1.10. Do you want a response to come back, or do you want to shut down at the ICMP to not allow people to ping? So that's one thing. Like if somebody's coming into your environment and they're trying to find vulnerabilities. They'll use Nmap or something else to try to scan your network and find their vulnerabilities. So they'll ping the different IP addresses. Once they ping the different IP addresses, they'll go through and try to connect with different services, and this will show them what's available. So one of the arguments is that you should shut down things like Icmp. If you shut down Icmp, computers will not respond to these ping requests, and therefore it's harder to find them. On the other hand, if you're trying to do troubleshooting and you shut off Icmp, then none of your computers are going to respond to your ping requests either. So you're going to make troubleshooting a bit of a pain in the butt. So again, this is where we go back to that whole art thing, right? Do you have Icmp turned on or do you have Icmp turned off? Depends on what your particular environment is. Then when we go back past that, we start thinking about things like backups. So if there is a failure of your systems, if your database cluster fails, your Active Directory systems fail, whatever else, when you think about backups in the modern world, don't necessarily think about backup to a tape. So a lot of people, when they think about backups, they think about, okay, I'm going to back up the operating system to a tape or to some, external media. When you back up, it's going to be the operating system, it's going to be the software, and it's going to be the records or the data that's residing in that computer. One of the things to be thinking about in the modern world, since we do use so much open source software nowadays, full backups, the reason that we needed full backups back in the day is that we used Microsoft. And all the pains in the butts go back to Microsoft. The reason was why we needed full backups back in the day as far as Microsoft was concerned, is that Microsoft, when they sold you a product, they also gave you a license key. Basically, when you installed the operating system, when you installed the product, you also had to put in the license key, and after a while, you also had to go through this whole activation system, right? So you put in your license key after you boot up your computer, and it goes to update for the first time. Then you actually have to activate your license, blah 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 blah. So why you needed a full backup of absolutely everything is if you had the data, and you had an OS CD, and you had the software CD, but you had lost your license keys, it was going to be a bad day for everybody. Right? Again, PTSD flashbacks. Having managers hand me disks without license keys and say, no, don't worry, we got the disks. Right? So that's why you needed a full backup of the operating system and the software and what else was on the computer. You needed that. In the modern world, a lot of people are using Linux. Again, you're using Linux, open source software, that type of thing. Or you're using some kind of software where whatever the licensing scheme is, it's kind of like an automatic configuration type of deal. So one of the things to consider is, do you need a full backup anymore? Maybe you just need a database dump, right? If I am able to dump my database and all I have is the database files, and then if my system fails, all I need to do is reinstall Ubuntu, or reinstall my MySQL or MariaDB or whatever else, and then import all of my database records. That's good enough for me. I don't necessarily need a complete backup of the entire system. Necessarily, I may need a backup of the system, but that is just one thing to be considering now when you think about backups. And again, the whole idea is, can you just back up the database tables? Essentially, can you do an export of your database tables, simply have the database tables? If a system fails, just simply reinstall a new operating system, reinstall whatever software it is you're using, and then import the data that you need to import. Something to be considering. And then disaster recovery. One of the big things with disaster recovery is the idea of how long until services are accessible. Again, remember, the difference between a backup solution and a disaster recovery solution is a backup solution makes sure that you keep your data. You do not lose your data. Doesn't really say how long it'll be before that data comes back to a useful format for you, right? If you back up your email, right? You back up your email onto a tape drive, right? All of your email is on that tape, but it's not actually useful to you, right? As long as the email is on the tape, I mean, it's there. You can't really do anything with with it, right? Disaster recovery, the idea with disaster recovery is how quickly can you get back to usable services. Again, if a tornado comes through or whatever else, wipes out your entire server room, how long before your CEO and your secretaries are able to do emails again, able to access their CRM solution again, able to log in with their Active Directory accounts, the whole 9 yards. Things to be thinking about with disaster recovery is basically failover solutions. I talk about high availability failover, really awesome. If you don't have high availability, get high availability. The idea with high availability is that you have basically 2 or more physical servers. They are exact replicas of each other. If one of these servers physically fails, power supply fails, CPU fan fails, whatever, it dies the way things do. Basically, there's something called a heartbeat signal that's going back and forth between the 2 servers. When the heartbeat signal for the one physical server fails, the other server reads that the other one is down. Basically, it comes online fully within however many seconds, and your end users do not even realize that there was a problem. What gets really interesting with failover is you can actually have high availability between data centers. It's a little bit more butt clenchy than I want to deal with in the real world, but I have heard about this in the real world. So in order for that heartbeat signal to work, in order for high availability to work, the latency between the servers has to be below a certain amount. So don't quote me on this, but with data centers, with fiber optic connections, it's something along the lines, if you can have data centers like up to 30 miles apart, with servers in them that are acting as high availability, so that if one entire data center fails or goes offline for some reason, the servers in the other data center can basically flip online, and again, nobody realizes that there is an actual problem. So again, when you start thinking about things like failover, actually do some research on this, because it does get interesting in the modern world. Again, you think about failover, you're like, okay, there's one machine here, and there's one machine here, and one fails, the other one comes on. Yeah, sure, right? But are you thinking about it from, hey, you could be renting space in a co-location facility, or renting space in 2 co-location facilities. Let's say where I used to be, up in the Baltimore area. So you might do something like, well, I'm going to get one co-location facility in Herndon, Virginia, and then I'm going to get another co-location facility somewhere on the other side of Washington, D.C. So they're only about 10, 15 miles apart physically. We're actually going to set them up for high availability. So if one goes down for some reason, the other one stays up and running, basically fails over. Something to consider about. And then again, with disaster recovery, there's something called disaster recovery as a service. Absolutely awesome. Take a look at Veeam, V-E-E-A-M. Basically the idea, all of your systems get backed up as virtual machines. They can essentially get uploaded, backed up onto the cloud to a disaster recovery as a service provider. If your entire infrastructure gets wiped out by a tornado or whatever else, you can spin all of those systems up as virtual machines in the cloud, providing services to your users until you can solve your problems, right? Nice. Then we have intrusion detection. Again, one of the things to be thinking about with this whole layered system is how do you know if somebody's inside your infrastructure? How do you know that there's a problem? One of the things you can use is something called a honeypot. So if you have any kind of large-scale infrastructure, you should definitely have honeypots. Well, we'll do a full class on honeypots. There's a lot of cool things you can do with honeypots. Basically, the idea with a honeypot is that you set up a server, or you set up multiple servers, and you basically make them open to the entire local infrastructure. So you open up, port 80, you put Apache, your IIS on there, you open up FTP, you open up SSH, you open up all of these services, you turn logging on to high hell and back, and then you just sit back and see who the hell tries to log in to SSH to one of your honeypots. Because here's the reason, right? If you set up a server, especially if it's just in your server room, you spin something on virtual machine or whatever else, and you open up SSH, nobody in your environment should know that it exists. Right? Again, if you just spin up a server and you simply open up SSH, and you're just in a normal office environment with salespeople or whatever else, Nobody should know enough to even try to go looking for that open SSH. The only person that is going to try to go after that open SSH port is a hacker or some kind of bot type system that is constantly scanning the network, looking for things like open SSH in order to try to do a brute force attack against that system. So basically what the honeypot does is you open up SSH, you sit the system, you do not tell anybody that the system exists, you don't tell anybody that the honeypot exists, and then all you do is essentially you wait for that honeypot to get attacked. So all of a sudden you start getting log files that somebody is trying to log in, using SSH, and this is the IP address. Once you know what the IP address is, you can go with whatever auditing system that you have, and you can either see, is this a normal computer that's supposed to be on the network, a normal user computer, or is this a Raspberry Pi and somebody's doing an Nmap attack against you, right? Like once you use a honeypot, basically those are put out there to look for weird things on the network. So that can be very useful. Beyond that, for intrusion detection systems, there's a crap ton of intrusion detection systems. We'll probably have a different class on intrusion detection systems too. Basically, these are systems that are set up to basically detect intrusions and issues. Again, anytime there is scanning on the network, anytime that there's nefarious activity looks a certain way. And so if you have intrusion detection systems, it looks for these things that basically look like nefarious actions on your network, and then it will tell you, give you a whole bunch of log information. You can go and try to solve the problems. Then we get to service agreements. Service agreements, yes. Just say yes to service agreements. Again, this is one of those things. CEOs and noobs hate service agreements. Old school IT professionals love service agreements. So you go out there, you buy this fancy new piece of equipment, you buy a firewall, you buy some kind of intrusion detection system, whatever else, and then you spend a couple $1,000s on it, right? Well, thank God. It may be expensive, but at least we only have to pay it once. That's what noobs and CEOs think. No. You've also got to pay for the maintenance agreement for these things. Maintenance agreement, service agreement, whatever else. Basically what these service agreements are is once you spend a stupid amount of money on the equipment, then you spend an additional amount every year to get a support contract with the company that sold you the equipment. This generally provides you things like updates, again, those the firmware updates, the operating system updates, definitions, all of that kind of stuff. But beyond that too, it'll also be a service agreement to provide you support if there is a problem. One of the big issues, in the real world of IT is there's just a crap ton of stuff out there in the IT world, right? If you go into a real infrastructure with a lot of servers, a lot of different client computers, there are a lot of things to understand. And many times, your employees, your IT staff are simply not going to know everything. I mean, don't tell the youngins this. But the old people don't actually know everything. There's a lot of stuff we don't know, right? So the issue is, right, is you're going to have a problem, especially with your devices. At some point, you are going to run into a problem, and your people are not going to know how to fix that problem. It might be a security issue or something else. If you have a service agreement, maintenance contract, whatever else, with your vendors, when you run into the problem, you can call them up and say, hey, how you doing? We're having this problem. Can I get some help, right? So you install a GeoVision digital surveillance system into your infrastructure. I don't know, you're using a checkpoint firewall. For some reason, people in the outside world are not able to access the internal surveillance cameras. The CEO wants to be able to see what's going on. You can't figure it out for the life of you. You call a checkpoint firewall. You say, hey, we have this maintenance agreement. Why the hell is GeoVision not working? Again, one of the important things in the technology world is everything is simple, right? Technology is so simple. It is so simple. But it's simple after you figured out what the problem is, right? It takes you 2 months to figure out how to solve a problem in 2 minutes, right? So you are probably only going to ever set up one GeoVision digital surveillance system, and you're only going to have however many firewalls you have. And that's it. So you're only going to get that amount of experience. Checkpoint firewall, right? They are dealing with clients day in, day out. All they do is sell equipment to clients, right? So they have dealt with 2,000, 3,000 other clients that have also used GeoVision digital surveillance equipment and have also tried to do exactly what you're doing. So they figured out a long time ago what the problem is. And so when you call them up and you say, hey, I'm having a problem, what they'll ask is for, many times they'll ask for administrative credentials in order to get into your system. You give them the administrative credentials, they go in, they type away, and all of a sudden your problem is solved 5 minutes later. And again, what is awesome in the technology world is you see how similar all humans are, right? When your user complains about how much money an IT person gets paid, it's very easy for you to get insulted and be like, you don't know what we had to do. What's really funny then is to see IT administrators then complain about the $500 or $1,000 per year for maintenance contracts for these vendors so that they can call and get a problem solved in 5 minutes. I can't believe we pay these companies, $500 a year, and all we ever use them for, we only use them for 5 minutes a year. Yeah, that's kind of funny. All right, but anyways, so one of the big things to be thinking about is with your security layers is that you have other people to go to. If you are having problems that you are not able to resolve, the big question is who do you go to when you've run out of tools in your toolbox? And the service agreements are going to be a hell of a help. Again, one of the things when you go to your executives, just don't demand it. Again, a lot of people want to be demanding. You will. That doesn't work too well. With the service agreements, again, when you talk about licenses, when you talk about service agreements, the best thing is you just walk into the executive and you just act like it's completely and utterly normal. It's like breathing oxygen. It's like drinking water. It's like paying your utility bill. Right? That's the whole thing. You don't go in with these service agreements going, oh please boss, I'll buy the service agreement. Right? Don't walk in there. Just like, hey boss, yeah. So we're buying those checkpoint firewalls, They're gonna cost about $3,000 a piece. So I got the agreement on that. One of the things when I was talking to them, they have the maintenance agreements that we're going to need just to make sure when you talk with the CFO, those are going to be an extra $500 per year per device. We're buying 3 of these things, so it's just an extra $1,500 a year. So I just need to verify that you do understand that we are going to be paying those. Yeah, okay. Again, one thing whenever you're dealing with managers is that if you make them think it's optional, they will assume it's optional. It's like, well, I don't want to spend $1,500, and my cyber guy is making it seem like it's optional, so I'm just not going to pay for it. You just look at them and go, well, you don't have an option. Well, what are your options here? Well, I don't see any. Buy the maintenance agreement. But again, one of the big problems that you can have, especially with technology professionals, is again, a lot of technology professionals think about spending money with their own pocketbooks. All right, they think about their own wallets. They think about their own checking accounts. And a big thing to be thinking about there in the real business world is this isn't your bank account, right? Again, you have to be reasonable with it. You can't be freaking stupid when you go in the executive, or they'll fire you. Or they'll fire you. But it is like this is a business. Remember, like a $15 hour employee costs like $3,000 a month. Like that's what a lot of people don't think about. Like $15 an hour. So that $15 an hour minimum wage people talk about. That is $3,000 a month. Right, running payroll can be enough. I talked with one of my clients, and their utility bill was $10,000 a month. Right, and so one of the problems you can have, especially a lot of new people in the profession, a lot of people that again they get so stuck in their own head, they're thinking about their pocketbook, right, and so they don't want to spend $500 a month or a couple $1,000s a month on these maintenance contracts. But the reality is to the business, it's peanuts. Again, I talk about that with Macs. What I find funny, again, having been on YouTube since 2009, is a lot of people give me crap about using Mac computers. Oh, I'm a sheeple. Who would spend $2,000 or $3,000 for a MacBook Pro? One of the things I try to explain to people is that you're budgeting off of your bank account. Right? If you're dealing with an IT professional, especially coders are making anywhere between $100,000 to $250,000 a year. And that's most likely not including their additional benefits, might not be including their bonuses. Right? So when you look at somebody that you're spending $100,000 to $200,000 a year for, $3,000 for a MacBook Pro ain't nothing. Like literally ain't nothing. It's like what the hell ever. Again, if you have a Windows laptop that's $1,000 and a Mac, Apple laptop that's $2,000, you're paying somebody over $100,000 a year plus benefits, everything else. That difference is freaking irrelevant. No CEO cares. They do not care. Right? And so that's one of the big issues you can have when you start running into these buying these additional services, is you start thinking about what your bank account would support, and then you don't sell what the company actually needs. And then finally, basically with all of this, when we're thinking about the layered security, is auditing. Never stop auditing. Basically, you should have systems that are mapping out your network at least once a day. Should be looking for open services, should be looking for any kind of quirky problems. You should be looking at log files, the whole 9 yards. Just because a device wasn't hacked yesterday doesn't mean a device won't be hacked today. If you do not continue auditing, then again, you're every time you audit, every time you do this whole security procedure, hopefully you are secure for that exact point in time. The minute that you are done with that audit, 2 seconds later, your entire infrastructure could be hacked. You only know you're secure at any one point in time. So you need to continue the auditing process, continue mapping out your infrastructure, continue looking for vulnerabilities, again, continue with the honeypots and all that kind of stuff. Make sure that day after day after day after day after day after day after day, your environment remains secure. Because again, one of your employees or one of your executives can go home, they leave their computer open as they go out and do something, their kid comes in, starts looking at a whole bunch of porn sites. And all of a sudden, that executive then comes in, plugs into the internal network, and all kinds of hell break loose past that. So again, and that's one of the reasons too, when I talk about these zero trust environments, is we just don't know we don't know what happens with computers when they leave the workplace, right? Again, back in 2000, most computers were desktop computers. When we gave people computers back in the day, 95% of the computers are desktop computers. So salespeople and executives had laptops. Everybody else had desktop computers, right? Because there's just no reason to give them laptops. Nowadays, with so many people having laptops, the reality is we don't know what happens with these computers when it goes out of the work environment. We don't know what they do with these computers at midnight or whatever else. If they get infected and then they get on the internal network, all kinds of hell can break loose. So continue auditing, continue looking for problems. And there we go. We get to the end. Yay! So this is the idea of having layered security within your infrastructure. Again, the idea should be is even if somebody has root credentials to your important servers, that it's essentially irrelevant. If SSH is not open, then they can't SSH in, right? If you have ports locked down, so only people within the local network are able to connect to those ports, then if somebody's on the external network, they're not able to connect to those ports. If you have your servers all siloed off, then even if somebody compromises one of the servers or compromises one of the host systems, then they're not able to easily access those servers that are siloed off behind routers and firewalls, right? When you have the antivirus, when you have the security policies, when you have the privileges, when you have the sharing permissions and all that, when you have all of that set up, that is layer after layer after layer after layer after layer after layer, so that even if one of the layers is compromised, the other layers should keep there from being a problem, should keep your systems from being screwed over. Again, that's where we start talking about the ransomware. There's this whole idea right now that we need more cybersecurity because of all these ransomware attacks. We need better administrators. How many people out there want to put money that there was sharing permission set up so that wherever the database file was for these databases that keep getting encrypted, that basically somebody was able to get through that share permission in order to encrypt the database? That's just dumb. That's just dumb, right? If we have layered security, it keeps that kind of problem from going on. And so that's really all there is to it. So this is the fourth part in the cybersecurity curriculum, and we will keep trucking along. Again, the big point that I will make out here is you'll notice I keep talking about relationships, I keep talking about communicating, I keep talking about, discussing things with all of the end users and all the interested parties, and that is going to be one of the major things to be thinking about when you're dealing with cybersecurity. You need to be thinking about what resources are available to you, what are the financial resources that are available to you, what does your CEO want, how do the employees go about doing their actual jobs, and again, the more people that like you, the easier it is to get them to go along with whatever it is that you're asking them to do. The other thing, again, is that whole sales process. Again, when you think about selling the idea of service agreements, when you think about selling the idea of getting the appropriate licenses, that is a sales process. So many IT professionals think that this is completely a technical game, with client access licenses or service agreements, right? But if you do not understand how to sell this to the CEO, to the CFO, to the manager, then they're just not going to write the check. Or you're going to run into the problem with that poor guy that I knew where they did write the check. They wrote a check for $5 million in equipment. You should have seen this guy. This guy was a high-level professional. Basically babysitting $5 million of boxed equipment. No number of best practices will keep you out of that problem if you can't actually discuss it with the executives and make sure that they are actually on board with whatever it is that you're trying to accomplish. So anyways, that's all I've got to say for today. Again, do remember that these classes are free to the end user. It does not mean free. All of this stuff costs money, so if you'd actually like to support what I'm doing, think about throwing some money into the crowdfunding link, wherever it is. As always, I enjoy doing this class, and look forward to seeing you on the next one.